showing you the video of the late version of homework 6. I will just let you know that there's nothing hidden in my room, and what's on the table here is a constant sheet and the formula sheet, the paper I'm going to work with, and the problem statement. So, without further ado, let's get started. Also, I think the resolution has some problems, so I'm gonna try to show my answer closer to the page to see if it helps anyone. First, following the formula we used last time, we can simply say it's n1 divided by s plus n2 divided by s prime equals n2 minus n1 divided by r, knowing r equals to 1.2 meters, which is 120 centimeters. And s prime is 18 centimeters. S and 1 as an incoming side equals 1.333 and 2 equals to 1. We will get that 1.333 divided by 0.333 times 120 minus 1 divided by 18 centimeters equals to s. Here is what I've used. And s equals to as a side note, I've simplified a lot of I've simplified the calculation for each individual number here as the 0.333 is the negative of n2 minus n1 because r is also negative, which cancels out with each other. And s would eventually be negative 24.11 from calculation cm, but obviously we're supposed to use the number 24.11 cm. So h equals to s minus 10 cm equals to 14.11 cm, which is that. And now we know AH equals to V equals to mass divided by density. This is what we know here, and this is where we'll begin the calculation. Now, we also know inside of the perfect insulator with a large amount of water vapor. So for this part, we could simplify it as Q in plus Q out equals to 0. Q in is the melting of water, sorry, the ice cube. So the melting of the ice cube is latency fusion heat times mass ice plus mass ice times specific heat capacity of water times 100 Celsius equals latency of vapor times mass of vapor. We know this because there's way too much vapor, and then we'll never get to the point where we start cooling down vapor. We'll only be able to condense a part of them. Moving the negative latency of heat for condensation to the right side, we will get a normal latency for vaporization. So plugging in values here, we will simply solve for the formula, which gives us m vapor equals to 0.8344 kg. Now we know m ice is 2.50 kg. So m total, which is m vapor plus m ice, equals to 3.334 kg, which, plugging it back into the equation, since density is already given as 1 kg per kilometer cube, we'll be able to get that A times 0.1411 meter equals to 3.334 meter cubed. Throwing it to the right hand side, you can see this is the equation I'm using in order to get the mass of vapor that is condensed, and the mass of ice that is condensed, that is melted, is already given. The mass total is these two plus together, which is this, plugging that over here, and since the density is 1, we simply do unit conversion divided by the height we found. So this will give us a final A of wait, actually something's a bit off with the, wait, hold on a second, something's a bit off. Oh yeah, fine. Sorry, I did a bit of miscalculation. I'm putting 100. I'm putting 1200 instead of 120 for the for S. So S should actually be 25.256 centimeter. So H is actually 15.256 centimeter. So we need to plug that in over here. So 0.15256 meter, 3.334 divided by 0.15256 is 21.85. A equals 21.85 meters squared. Here's our final conclusion. And here is my edits on the actual height. So, yep. That is the whole thing. Thank you for watching. Have a great day. Bye.